So, my tryst with Lucene started in 2009 when we were building a movie recommendation engine based on a vector database of around 50,000 attributes on global movies. And then we built something in Java which would work with Lucene. And then I discovered one day in 2010 there is some guy called Kimchi. And there is a whole cluster setup based on Lucene. So that's when I discovered Elasticsearch, and then so that's how is my tryst with Elasticsearch. And I had a conversation with Shay in 2018 as well. We'll see the email snippets here. So I've come 1500 kilometers from Himachal Pradesh, and we live in the mountains. I've come to meet Shay especially and to present something we made with a lot of love from these mountains. And this is where our office is, this dot you see here, and our co-working space. And I'll just share shortly about my journey. So I'm founder of Godspeed. I've been in tech since 17 years, and used to love working on Vim, so back in those days. And what we basically do at Godspeed is we are a DevTools company. And our hero product is what we believe is world's first meta framework for microservices. We'll quickly look at that as well. And but what we built before that was Elasticgraph, which I'll present today. So it started in 2014 when we were working with an Elasticsearch cluster of 230 nodes, and doing massive crawling and lots of stuff on top of it. So there we would always write a boilerplate like a for loop making bulk queries. All right, I hated that. So I wrote a small utility, and it started from there. I put it on GitHub as well as a Apache 2 license project. And then we started getting some downloads, 200, 250 every day as well. But then over my journey, I just got a bit disillusioned with FOSS, and that's another topic we'll talk about it. So then I decided to take that back, and I really believe in source available approach, and that's what the journey we are taking in Godspeed as well. All our code is on GitHub. It's free for non-commercial use, but paid for commercial use. And we basically don't limit on features, but you get everything even in free version. So we'll see more of that later. So then, yeah, this is where it all happened, and my personal journey as well. Going forward. So there was a time in 2018 when this module was already built, and it was actually our first adoption was by His Holiness the Dalai Lama. So since I live in Dharamshala, Dalai Lama lives in Dharamshala, we got the project. So they needed a digital archive management system, and we started basically writing a lot of boilerplate. So then decided, oh no, we should have a configure over code approach, and that's when Elasticgraph version 2 emerged. And then in 2018, I had an email with Shay. So that time I was also on just a personal spiritual journey. That's why I went to mountains 12 years ago actually. So I decided, one day I just felt that enough of running behind money, and this is just the world is going around like this, and I had some more thoughts. So I decided to take a sabbatical. I needed to just reflect inside. So after that time, that's the time I mailed you, and I shared about how I'm a big fan of Elasticgraph, or Elasticsearch, sorry, and this was a whole thread. Then you really appreciated the project, and you gave me a pat on the back. You may not remember it, but it meant a lot for me. Having spent 2,000 hours writing things on Vim. So yeah, so that's what he said, Shay, that when you come back after a sabbatical, if this is still where your passion is, you can continue. And that's how the journey progressed. So right now, after Dalai Lama, there are some other clients who have adopted it. Pine Labs is one of the biggest fintechs in India. And some other companies as well are using this module now. So I came back in 2021, after 3 years, and somebody hasn't still made what we have. So we got adoption for the same thing. So what is Elasticgraph? Elasticgraph is a unique ORM in Node.js over Elasticsearch. Okay, and you can just install it. And what it does is extends, provides some additional capabilities on top of Elasticsearch. For example, relationships. So you can define your model with relationships, and then you can do joins in the search query. There were conversations. This is application level joins. But as developers, we write joins, right, in our code. So rather, you just configure them here, you send joins in your query, we'll see, and you can do very complex modeling. Then also denormalization, and so there is, like Elasticsearch is not a relational database, right, primarily. So this was another thing that we extended. So we will look at algorithms. So it helps you maintain a denormalized state of your data in Elasticsearch. And the next is basically, again, data dependency capability. Sometimes one piece of data depends on another piece somewhere else in the relationship graph, right? So automatically calculating those dependencies. It's multilingual, and then as well, we have worked on some optimization and performance as well. So let's look at the top level benefits. So there's a lot of functionality that is there. It is based on configure more code less philosophy, which is everything we do at Godspeed is based on this philosophy. Second is schema driven development. So if you create your schema, your CRUD APIs, a lot of stuff, Swagger spec, and even test cases going forward should get generated. And there should be better performance. So it is basically optimized for graph search. I put a quotation on the graph because it's not a graph database, okay? Typical graph database, but we often do queries like give me people whose city.state.country is India, correct? So then we want denormalization, or we want to do such an aggregation, break up people by their countries, So those are very optimized, and as well you can write your ETL scripts. If you're writing, you can do in a very optimized way here. And it basically reduces load on Elasticsearch cluster and on your microservices as well. So what are the key features? There are a bunch of key features we'll go through, and we'll go one by one over these. And starts with relationships, joins, denormalization, multilinguality. There's even a UI that we generate as well, and we'll go through all of this. So how does the modeling look like, right? So basically, this is your entity. It's TOML files. You define all your fields, and it has some extra annotations. As you can see, that this is a multilingual field. I want to enable auto suggestion. This is also encrypted. I also want to do sorts on it. It will generate the Elasticsearch mappings, okay? Then these are your relationships. We have our own DSL to define relationships, one to many to many, and you can define your relationships as well. And after that, there's even when you define your schemas, you reuse common schemas. For example, in this case, in the Dalai Lama office, lots of fields were common between audio and video. So we didn't want to redefine them in both places. So hence the video sort of extends the schema of the audio as well, okay? Then the next is joins. So this is what you do. So this simply extends the Elasticsearch Node.js client, okay? That's all. All you need to do is add a deep after your Elasticsearch, es.deep. So therein you can specify what you want in your response, similar to GraphQL-like experience basically, okay? And then in the response basically, you get the join data as well. And then maintaining the denormalized graph state, right? Actually, before this, I would like to go through this particular slide. So what are the graph algorithms we had? I've seen a film. Who has seen the film called Butterfly Effect? Have you seen? No? So you've seen.
But we know what is that.
You know what is that. Okay. So if for those who don't know, like one flap of a butterfly's wing in one corner of the world can bring a storm in another corner of the world, okay? So when you update one part of a node, right, in the whole graph, this may affect other nodes. Especially if you use denormalization, data dependencies, or you may want to take other actions in your graph if one node is updated, correct? So then the ability to traverse the relationship graph and find out all the affected nodes is what these algorithms have been built, and I've basically worked on them along with the team. So now using these algorithms, we have written a couple of handlers. One is for denormalization, all right? So all you need to do is in a file, specify my events should store my speaker's person's name also. Okay? So whenever you create an event or link with a speaker, the name will be there. Whenever you update the name of a speaker, this ORM will go and update it in the entire graph as well, that the speaker's name has changed so that you can do the search. And this is how the index document looks like. So as you can see, within the event object, we have stored the field speaker's person's name. Speaker person name as well. And next is dependency management. So as you can see, it was a digital archive as well. So the folders, files, edited content, raw content, a lot of stuff was there. So we can say that a folder has a list of types of files. I have a PDF, PPT, what all, right? So I can simply type the folders file types field is a union of these two. Child folders.type and child file. So it will recursively go to your entire tree and calculate the file types, right? And similarly, a conference, all speakers include the speakers of all the sessions. So I don't need to go and code it in two places and maintain this manually. Next is multilinguality. So in a common configuration file, you support what languages you want, and then all documents will start getting these fields of the languages there. Okay, so then you can create multilingual databases. And again, if you get in a response, as you see in line number 6 there, there's a langs field. So along with search query, you can say I want response in these languages. So accordingly, the response will come. And then encryption and decryption. So if you want to encrypt any particular column, a key in Elasticsearch, you will say encrypted true. And then, of course, you set up a key as well, and you can do a plain text search on the encrypted data. And as well, when the response will come, it will be decrypted. All right. So next is query batching. This was the most painful area. I talked about the boilerplate, right? So as we all know, if all the developers, right, whenever these search queries come, we keep an array somewhere, right? And then we keep pushing to the array. When there are 100 elements, do the bulk query, then distribute response, send back to all the responses, right? So here what we do in a configuration file, we put in the batch size or timeout in milliseconds, okay? So all my Elasticsearch queries, I've said that my index query, either I wait for a batch of 200 queries in my microservice to get collected from anywhere, I may be calling that, or let the timeout be 30 milliseconds. I don't want to wait for more than 30 milliseconds. Then the batch bulk query will be fired, and this is how you extend Elasticsearch again, es method name dot collect. This is what all you need to add, and the batch queries will be going on. For example, es.search.collect effectively. Then we use in-memory caching as well. So this solves n+1 problems and also helps improve performance. So I will come to the script as well. So in memory caching, you can set up your variables, you can cache your entities, you can even cache your Elasticsearch responses. So the whole graph algorithms extensively use caching if you write those scripts. And so what are the features? One, the variable names are immutable so that you can do concurrent access and updates within the same workflow. And these are used in all the deep graph functions and all the dirty entities. If you update any entities in the cache, it will be flushed eventually to Elasticsearch. And what are the benefits? It solves n+1 query problem. It reduces the load on the Elasticsearch cluster and on your microservice as well, and hence we achieve more efficiency. So there are some profiling results as well I'd like to show. Yeah. All right. So we just did a sample profiling with Mongoose. Okay. This is just very fastly done testing. So in the first case, I'm simply creating a user in Mongoose. The test case is basically there are users, states, and cities. All right. So we simply store JSON in Mongoose. Second is we store user in Elasticgraph. Okay, with all the graph algorithms, I will save a user with the city name with the link. Okay, so it will run all the graph algorithms for denormalization, and then basically also store with Elasticsearch and batching. So these are the performance, right? If you look at the throughput, so in Mongoose anyways it was 109. Elasticsearch was of course faster. Even with the graph algorithms, if you see, we achieved a better throughput than Mongoose. Why? Because we use caching internally, okay? n+1 query problem has been solved effectively. And again, if I do batch queries, I don't run the deep algorithms, just save as it is, just the bulk process, right? It helps me achieve 3 times the output or 4 times, all right? And as you see, that even though the network usage has gone up, the CPU and RAM is consistent, all right? Can we go down, please, a little? So now let's come to the search, the real fun part. So why, denormalization is useful for write less and read more scenarios, correct? So now this is the search part, right? So let's forget Mongoose. Anyway, it's very obvious if I do queries over 3, indices. Let's say I first get country ID, then I search for all cities, then I search for all states, and then I query user which has array of those states. It will of course be slower. And if I don't use caching, it will be even slower, correct? So, but we applied all these algorithms and with join and without joins. All right, these are the performances. If you see that there is not much difference even if you do joins. Again, the n+1 query problem, the caching helps us solve it. And now let's look at this interesting. You see a lot more data has come here. The throughput is much higher, 513 responses per second, but the CPU and the RAM remain consistent again. Correct? In fact, it's slightly lesser than Mongoose. That's it. We can switch. Now, so, okay, one of the funs we developers have, right, is writing our own scripting languages, correct? So we recently discovered a language, a Bhai language. Some people
Bhai
are
lang.
about it, right?
Bhai
Bhai
lang.
lang. Correct?
It got viral a few days, a few months ago, right?
Yes. So, again, when we were writing this project, there was still, even after configurations, everything, a lot of code and JavaScript was being written. So then, I realized lots of ETL, effectively, because they had 60 tables. Migrating all of that from the old database to the new database took a lot of effort. So just went ahead and started using PEG.js and created an English-like language. So I iterate over this index where the Elasticsearch query is there, and it uses variables as well. I showed you the variable setting and all. Get 25 at a time, flush every 5 cycles, wait for 100 seconds, milliseconds before every new iteration. Okay, this is a for loop effectively. Now get event with this ID. I'm using variable. If you see the asterisk here. Okay, so if event is empty, stop here, display here, search this, create what response comes, create this variable out of the response. Then there's a concurrent async execution over the response as well. And if you create something, if it doesn't exist, then create a new thing. So these was, some of the features we built. In between, you can write JavaScript if you need. So this is a scripting language basically that was created, and this 39 lines of code that we see here, if it were to be written in JavaScript, it would take at least 400 lines and would be very less maintainable as well. It's difficult to read the code. So this is, yeah. And now comes with Godspeed, right? So what is Godspeed? It's a meta framework for microservices. What we mean by meta framework, this is a different dev tool now, but I want to show a couple of features, how we integrate Elasticgraph within this microservices framework. Okay? So a meta framework means it's a framework of frameworks like Node.js, Spring Boot. So it works with everything we do in building modern microservices, the engineering part, right? Plumbing things together, caching, telemetry, all of things. What if there was a higher level fourth generation abstractions in YAML, in which you can again configure everything which is not your business logic. For example, caching my database calls, right? So a lot of these stuffs are provided. They are common, whether you work in Node.js, that's what we have right now. Java is coming next. This is the architecture. So you start with events, right? And there are various event sources. Anything can be an event source. And then event source, how do they trigger your workflows, right? There are either sync mechanisms or async mechanisms, correct? Sync mechanisms would be GraphQL, REST, or a gRPC call. Async will be a message bus socket or even a cron job. Okay? So then your workflows are triggered, which do common things like authentication, authorization, validation, caching, and various data sources. This is the second abstraction we have, that it could be Elasticsearch, MongoDB, or a third-party API. So first thing that we have for Elasticgraph as a plugin for Godspeed is automatic auto-instrumentation in OpenTelemetry standard. So whenever an API calls are happening, you see how much time Elasticgraph took, or Elasticsearch client, right? And so this can be added to Grafana, Kibana, or any such destination which supports OTIL. And logs, traces, metrics, everything is exported. The next is a schema-driven development paradigm, right? That if I have my database schema, which we do for all databases in the framework, can I generate the CRUD API automatically? So here is, we call the Godspeed Gen CRUD API. Imagine this is a plugin I've included in the data sources. So now I've created one instance of Elasticgraph, EG1 here. This is all the schema of Elasticgraph. Okay, either you can directly write these configurations, you can even write a Prisma file. And we convert even Prisma to these configurations, we support that. And then these are my workflows created for this module, create, read, delete, update, search, all right? And next, then this is how an event looks like in Godspeed. So Godspeed follows event schema-driven development, right? So all events, whether from Kafka or a RabbitMQ or HTTP, gRPC, all follow Swagger spec. This is how we define events there. Inputs to my microservice, right? So this is my function handler I want to call. The only thing that changes for every event is your URI. Okay? Wow. That's it. Except from that, it's a Swagger spec.
Just one question. Is it only with HTTP or even gRPCs?
We are adding gRPC, GraphQL is coming next. But the developer will write only Swagger spec. From this, Apollo server is created. We dynamically create the GraphQL queries from this. So idea is let's follow one standard way of development and we can have any plugin, right? So you have Express server supporting HTTP, you want to replace it. So your code should not change. So then we can add Fastify as a plugin and everything else, my event definitions, my workflows will remain same. So Godspeed supports YAML workflows. If you don't have much business logic, all you're doing is querying two data sources like GraphQL, combining response, returning it, caching them, sending telemetry, APM, BPM signals, retry, and such things, on error. So those things can often be done within YAML. Okay, but complex logic can be written in JavaScript. You can write JavaScript functions also. This supports inline JavaScript. And this is the function which is generated. EG1 category index. This is my input body data and whatever other things. The Swagger spec is also generated for this. So another feature which was there for Dalai Lama is the things for scanning your file system as well. So this is just a utility. If you give it a file system, then it will just scan everything and create the entire state. It will also index your text files and provide a search on top of it. Then we also created a user interface, again configuration driven data admin UI, which you can configure, and then you have a full data admin over Elasticsearch. You can handle all your relationships, multilingual view, all relationships are here. You can create a new relationship and link things together. So there's even something for manual work that can be done out here. So there's view, auto suggest, advanced changes, everything is there. And so yeah, this everything works on top of Elasticsearch. Then these are some use cases we have, like it's being used in Dalai Lama office. Then second is Pine Labs is loan origination, borrower profile, merchant reconciliation in Chai. And then there's again another movie recommendation service, one of our clients who came up. So, we've come back to that again. So it's being used there as well. It's like a social network, come movie search. So these are some of our current use cases. Our roadmap is firstly within Godspeed, we want to expose this via GraphQL, gRPC, and even socket protocol. There won't be a response. We actually have a socket server. So you send an event like a search, the socket will send a response via the socket connection. Okay, so that's how our UI also works. But you want to support other, then also RBAC and ABAC. So Godspeed provides a standard RBAC, ABAC mechanism over any data store. The plugin needs to just implement some interfaces. Then there's one way to do RBAC and ABAC, even till a column or a row level. Okay, so then along with handling large graphs. So one of the limitations of Godspeed is, right now it's an ORM. If you do denormalization over 10 million, let's say there are 10 million users in a country, and you change the name of the country and the country name is stored in all the users, that it won't be able to handle currently, okay? But that is something we want to bring, the capability, handle large graphs with graph algorithms. And then transactions is a question. I'm not myself sure, but I would love to see, because we have locking in Elasticsearch, right? So can we use, see, it is the use case when we especially use denormalization and stuff like that. It's for write less and read more scenarios, right? So it may be fine to actually lock things for a while if that works for us. Otherwise, we take our risks, right? So then Elasticsearch 7x is what we support. It started from 6x actually. We migrated to 7. We would like to come to 8. And eventually what I feel, and this is still a bit far away, is like have a meta ORM. So like have one way, like use Prisma schema, one standard way to define models for your data stores, and also maybe one universal query language. And those graph algorithms you've written are not coupled with Elasticsearch. So they can be applied to other ORMs as well. So we could integrate, for example, Prisma or Type ORM too, and support other data stores. So yeah, this is it. So let's say Godspeed, Elasticsearch plus Elasticgraph, I believe is a killer combination. So
you did everything in sabbatical leave actually.
Yes.
In the mountains.
I didn't make money, but I wrote this code. So yeah. Thank you. That's it. This is our website, godspeed.systems. There's documentation out there. You can install and run it as well. Thank you.
I think instead of denormalization, you can use faceting, right?
Correct.
That will solve the problem. Why you use denormalization?
You mean the facet search?
Facet search, yeah.
But the facet search, Will it achieve the same effect of having an indexed, stored state? It's in the index, it's stored time, index time, I've stored this data there itself. Will it have the same effect in performance?
It should.
Uh-huh. All right. Maybe someone can enlighten on that. Yeah. So I will check into it, but that time till Elasticsearch 6 or 7, I did not find such a feature. So in fact, if you go on Google, many people are talking about it. So we talk of the data enrichment pipeline. So, but that is only when you create your first time. But what if there are updates in the graph and you want to change later, so data enriching won't work that time. So Facet, I believe, would be something else. Yeah. Any other question?
Faces takes bulk of data.
It can aggregate.
It can aggregate, right?
Correct. But this is storage time. No? If you do aggregate by loading things in memory, combining, even if Elasticsearch does it, it will make things slower. That's the thing.
So your UI is on top of Elasticsearch, is it?
Yes, currently.
Real-time data of the relationships you are handling.
It consumes the configuration and it is generated, yes.
Okay, so it's like near real-time what there is.
Yes, it's via socket connection.
Okay.
Yes. So that's how
So
it is.
how do we integrate this? It's like, does
It's a
it
node
support
module.
serverless or-
It's a node module. Just an NPM module in Node.js. So you can use it with Godspeed as well, or you could use it in a Node.js project. Yeah. It will run in the microservice. You simply extend the Elasticsearch client. That's all we are doing.
Like I'm a Pythonic person, so I'm just wondering how.
Currently Node.js only. Yes.
It's a non-technical one.
Sorry?
It's a non-technical one. So how many people are there in your?
There we are a remote team. People come and go. We are 16 people total. But this is also community space. So anyone is welcome to come with your team. We have a co-living and a co-working space here.
In Bangalore?
In Dharamshala, Himachal Pradesh. Yeah.
Anyone is planning for a vacation in Dharamshala?
Yes.
Why not? Feel free to meet Ayush, yeah?
All right. Yeah.
All right,
Thank you.
folks.
Thank you,
Thanks.
everyone.
A big clap for Ayush.